Hey you guys, this video is going to be about replay attacks, Smurf attacks, password attacks, and privileged escalation. So a replay attack is going to happen over a network. It's going to be where information is captured over a network. Packets of data are captured. It's a kind of an access or modification attack. In a distributed environment, you're going to get some logon and password info that is sent between a client and some kind of authentication system, right? So in this instance, you can see the attacker grabbing the information, the logon stuff, the usernames and passwords and whatnot, and they can replay it later, hence the name. So you got user Bob over here, right? And Bob has a username and a password that he wants to send out into our authentication system. We'll call him auth. And we got our attacker down here waiting to grab it. So what's going to happen is Bob is going to send his stuff out off to the authentication system. Well, what's also going to happen is our attacker is going to get a copy of it too, so they can use it at a later time. So when they feel like it, they can send it off to the authentication system and basically circumvent all security measures that would normally be in place, because now the attacker is basically undergoing the same session that Bob is. So that's why you'll see, lately you'll see timestamps and session identifiers kind of paired with certificates of, logon information that make it specific. So if Bob sends in something, his username and password, he's going to come out with a special signature on it that could be different than when our attacker sends it. So if the authentication system is meant to only recognize a certain session and it's getting something else that doesn't match, it's obviously going to see that something is wrong. So one kind of note to mention is that this looks very similar, or may sound similar, to what the man-in-the-middle attack is. A way to differentiate between these two things is to understand that with the man-in-the-middle attack, your man in the middle is going to be really just intercepting data and kind of transferring it between a host or two hosts and a client, server, that kind of deal. With the replay attacks, the data is going to be captured specifically for the purpose of either storing it or using it at a later point in time. So a Smurf attack is going to serve to basically just mess up stuff on a network. What's going to happen is the attacker is going to spoof the target machine's IP address and broadcast it to the same machine's routers, so that the routers are going to think that the target is sending out some kind of broadcast, right? The attacker sent it, but it's going to look like the target did. Now what's going to happen is this is going to cause every machine on the network to respond to the attack. So let me give you a visual representation over here. We have our attacker at, who's wanting to cause some havoc. We got our victim Bob. And what will happen is our attacker is going to send a broadcast message, an ICMP, that's Internet Control Message Protocol, an ICMP request to our router. Now every single thing on the router is going to respond to it, and they're going to send out their the responses to the internet. And say this was a ping request, hit me back up with a ping, sent to the router. Router's going to go out to all the machines. They're going to go to the internet, and then Bob, because his IP address was being used, he's going to get slammed with all the data, right? And this is going to create a DOS effect, denial of service effect, that slams Bob out of his system. And so a way that you can get rid of this kind of attack from happening is basically just blocking ICMP traffic on a router. If you can do that, then Smurf attacks from external attackers, it's not possible. So, password attacks are going to occur when an account is attacked repeatedly by programs that are called password crackers. Now, what those are going to do are send just a constant flow of possible passwords to the account in some systematic manner in the hopes of actually achieving, whatever password it is. This can move on to become an access or modification attack. And as you can see, there are several types of password attacks. The first one, the brute force attack, the best way to think about that one is in terms of smartphones. You'll see the 4-digit passcode being used a bunch. Imagine going in and typing in 0000, 0001, 0002, all the way to 9999. Eventually, you're going to get the correct series of 4 digits. So you can see with long, complex passwords, that can take a lot of time. The dictionary attack is the use of a database or dictionary of words and combinations of words to, create a password. And, if you just cracked out the English dictionary and started mixing and matching from there, that's kind of what the dictionary attack does. The hybrid password attack is basically just a mixture of both, a mixture of the brute force attack and the dictionary attack. The birthday attack is based on this neat mathematical premise that if at least 25 people are in the same room, there's going to be a solid probability that 2 of those people have the same birthday. That chance is only going to be increasing for every single person that walks into that room. So the same concept is used with password hashes, for example. There's a high chance, or there will become a higher chance that as time passes, if hashes are generated, new hashes, they're gonna equal the same value as the original hash. Now the rainbow table is going to focus on identifying some stored value. It's going to use values in an existing table of hashed phrases and words and compare them to values that are found, and then that allows it to greatly reduce the amount of time that's needed to crack a password. Now in terms of security measures that are going to be useful in combating these attacks, a lot of times you'll see a certain amount of password attempts before some kind of account lockout is done. That's a good way to protect your system. Also, sometimes you'll see with a username and password scenario where both are necessary, if you get one of them wrong, it's going to say username or password was incorrect, but it won't tell you which one. And that can be really helpful in not letting the attacker know whether they got the right password, wrong username, or whatever. So, privilege escalation, as you can kind of guess from the sound of the name, is where an attacker is going to get more privileges than they should have in the first place. With that, they're going to be able to basically perform things on some kind of program or system that would serve to mess around with it. This is best thought of in terms of rootkits. You can, see attackers getting root access, root or administration access to some kind of system. Well, this is the same premise. This one uses backdoors that are left by software developers in their programs. If there's a backdoor that's still left behind and an attacker can get into it, well, then they're going to have some heightened privilege levels. And they can perform whatever bad deeds they need to do. Another way to think of this is in terms of video game cheat codes. If you got this video game and it's, got the potential for putting in cheat codes and, you put one in there that makes you invincible or, makes you just able to do a bunch of, ridiculous stuff, that's kind of the same concept of what's going on here with the privilege escalation. Hope all these things helped, guys.